The core part of the IC protocol is divided into 4 layers. From bottom to top, they are the P2P layer, consensus layer, message routing layer, and execution layer. IC consensus occurs within a consensus committee inside a subnet. The consensus committee within the subnet is responsible for creating blocks. There is also a random beacon committee within the subnet, which is responsible for generating random numbers to determine the order of the consensus committee members. Members with higher weights have priority in block creation. In each round, the consensus committee creates blocks based on the weight ranking determined by a random beacon. For example, in the order generated by the random beacon, the yellow replica has the highest weight, and blocks from the yellow replica are prioritized for acceptance. Following that are the pink, purple, and blue replicas, and so on. The consensus protocol generates blocks in rounds. For instance, consensus is reached for the Genesis block in the first round, and consensus is reached for the 6th block in the 6th round. Within the subnet, there is also a concept of an epoch. An epoch comprises approximately several hundred rounds. Each epoch consists of a consensus committee and a random beacon committee made up of different replicas within the subnet. The first block of a new epoch contains the list of members in the consensus committee and the random beacon committee for that specific epoch. At the beginning of each round, replicas within the subnet calculate a weight ranking based on the random beacon generated in the previous round. The yellow replica ranks first with the highest weight. Consequently, blocks created by the yellow replica receive priority signatures from everyone, while blocks from other replicas are discarded. After the yellow replica broadcasts the yellow block, other honest replicas will sign the yellow block, initiating the notarization process. If everything goes smoothly, and the consensus committee only signs this particular block in the round, it becomes the sole block for that round, signaling the transition to the next round. By the way, a non-Genesis block generally includes messages received during a certain period after the last block was packaged, referred to as payload, the hash of the previous block, the ranking of the block producing replicas, the block's height. Once the block is composed, the replica responsible for block generation creates a block proposal, including the block itself, their identity, and their signature for the block. However, if unfortunately the yellow replica is malicious and tampered with the block, and this is detected by other replicas, it results in the failure of the signature authentication process. In such a case, the responsibility shifts to the second highest weight replica, the purple replica, to create the block. The system has a predefined waiting time. If no yellow block is received within a specified period, everyone anticipates the purple block in the subsequent time frame. Once the purple block receives notarization from other replicas, the replicas conclude the current round and proceed to the next round, H+1 round. Notarization only verifies the validity of a block and does not imply consensus attainment. It simply ensures that at least one block is notarized within the current round. If the block's information is correct, the replica responsible for verification first signs the block's height and hash. Then, they broadcast the signed notarization fragment, comprising the signature, hash, height, and their identity. When a replica receives a sufficient number, 2/3 of notarization fragments, they aggregate the signature fragments to form a notarization for that specific block. Having only one block in a round is ideal, but sometimes more than one block can be generated in a single round. For instance, in the 5th round, if the replica with the highest weight experiences a network interruption, resulting in the notarization of 2 blocks, it becomes necessary to proceed to the finalization stage. This specific process involves each member signing a unique block they have notarized, generating a finalization fragment. Replicas broadcast a finalization fragment for a block to express their support. For example, if there are 7 replicas, with 5 of them signing a finalization fragment for the purple block and 2 replicas signing for the blue block, then the final outcome will be the purple block being finalized. Finalization will select a unique block, eliminating any fork scenario.